The crowd watched the future being born. And then it burned. He stood at the podium like a king waiting for his crown. 200 investors, a phalanx of cameras, reporters with notepads like bayonets. Everything tuned to Richard Whitmore's smile. The Apex 8 hummed to life. 6 silver arms moving like choreography, quantum sensors whispering secrets. For 43 flawless minutes, the room breathed as one. Then the sound began. A tiny, impossible whine, almost a cruelty you could only hear when hope tiptoed away. Whitmore's grin slipped. Christopher Davis, his head engineer, froze at the console. "Unusual vibration readings," he said into his headset, the words papery, fragile. Whitmore waved the fear away like a fly. "Within parameters." The sound climbed, high, wrong. Sparks stitched the air. Metal began to scream. By the time the coupling blew, the hall had become an indictment. Orange fire showered the assembly line. Robotic arms convulsed like trapped beasts. Alarms hacked the silence into pieces. A 500 million system, a legacy built from Whitmore's garage to the pinnacle of Wall Street, shredded in a single televised heartbeat. People filmed everything. Cameras loved the fall of kings. 6 hours of frantic diagnostics did nothing but widen the silence. Consultants charged and left their invoices like battle scars. The founder who'd first sketched the coupling flew in, peered at the wreckage with the hollow defeat of someone who has outlived his own miracles, and said the thing every desperate man feared. "We need complete disassembly. Weeks." Investors' eyes sharpened into knives. 48 hours, or the check was dead. Without the funding, payroll would become folding chairs and closed doors. Whitmore retreated to the observation deck, a glass cage that now felt more like a coffin glass, and stared at the fallen machine. He had 20 years of a life invested in those servos and sensors. He felt it go cold. That's when Samuel Underwood moved. He'd been invisible in plain sight. Night shift maintenance, grease-stained coveralls, a tablet held like a secret, hands that had fixed conveyor motors and replaced burnt-out indicator lights for years. He was young, impossibly composed, and, to anyone who noticed, unmistakably handsome in an unmanufactured way. Strong jaw, tired smile, eyes that measured things others only glanced at. A housekeeping name tag pinned to his chest read, Maria Underwood, his mother's name, because she de-sewn his first working gloves and he never took it off. Samuel had been watching the whole demo from the catwalk, watching the way the vibration danced along a seam no one else had followed. He came down the stairs like a man delivering a verdict. "Mr. Whitmore," he said, voice low and exact, "I think I know what's wrong. If you want dramatic irony, here it is." The entire room heard those 4 words and interpreted them as a punchline. A janitor's son, a maintenance kid. Cute, right? Whitmore saw the uniform, the name tag, the dark skin, and the wrong kind of desperation in his own face turned everything cruel. Whitmore crossed the floor with the speed of a man who'd been denied mercy too long. He ripped the tablet from Samuel's hands and hurled it against concrete. Glass exploded like a cheap promise. "Your mama scrubs toilets. That's all you black people are worth." He spat, the words thrown like acid. He shoved Samuel hard enough to taste the hallway tile. The room fell into a hush, thick with the aftertaste of his shame. Samuel's balance rocked, his jaw flinched, but his eyes did not leave the coupling. There was no theatrical anger, no roar, only an internal clock resetting, the slow, precise calm of someone who knows his work. He wiped his sleeve on his hip, picked up a shard of the tablet as if it were a compass and said, "Quieter this time." "You didn't listen." Laughter muttered at the edges of the room, the kind that smells like privilege checking its reflection. But in the technical core, something had shifted. A few of the engineers who'd been too proud to look now found their shoulders, their hands, their instruments tilting toward him. Samuel began to speak in the only language that mattered to the assembly line, specifics. frequencies, microstrain distributions, a vector of heat migration along a bearing housing. He drew a quick schematic in the dust on a console and underlined a seam, the one the others dismissed as noise. Whitmore's face was two colors, terror and something darker, the old reflex of a man who'd once been small and now could not bear reminders of it. Samuel felt the shame, sure. He also felt the gravity of what would happen if he did nothing. $2 billion vanished, jobs gone, his co-workers' lives ruined. And beneath all that, the private, steady flame of someone raised in a kitchen that taught him repair and dignity in the same breath. "Give me access to the coupling housing," Samuel said. "I'll need to bypass the main AI loop and run a mechanical spectral sweep. If I'm right, we don't have weeks. We have hours." Someone laughed. Whitmore barked a laugh that was more like a cough. You break in and fix my crown?" He grabbed Samuel by the collar again, voice low and mean. "Stay in your place, boy, before I throw your mama on the street." Samuel looked at Whitmore long enough to see the man's fear like an exposed circuit. He answered like an engineer and like a son. "You already threw my mama on the street, sir," he said. "You just didn't notice she stood up." No sermon, no theatrics, just a line that landed like a bolt. Whitmore flinched at the implication. The room shifted. A dozen cameras zoomed in because conflict is good content, but the real contest had nothing to do with optics. It was a contest between reflex and reason, between the brittle arrogance of a man who'd built an empire and the quiet stubbornness of a kid who'd learned to coax machines back to life. They gave him 48 hours. The investors circled their checks like vultures. The founder shook his head and muttered, "Impossible." Christopher Davis felt something he hadn't felt in years, the small, hot ember of curiosity. He let Samuel near the console. What Samuel found wasn't magic. It was pattern. A tiny asymmetry in force distribution, a microfracture that sang at ultrasonic frequencies and then fed itself into the AI's control loop until the loop locked and the system froze in panic. It was a design compromise made in the name of speed, a labeled for production bearing replaced with a lighter alloy to shave milliseconds off cycle time. It was hubris dressed up as innovation. Samuel didn't yell. He didn't gloat. He set to work like someone assembling a prayer. He rewired, rebalanced, calibrated. He walked technicians through the fix the way a teacher walks a pupil through a difficult proof. Patient, exact, and devastatingly clear. As midnight bled into morning, the team that had laughed at him were the same hands now following his cues. Whitmore watched, a man slowly unstitched by humility and fear. Samuel's hands moved like someone who belonged to both worlds. The grit of nights under fluorescence, the precision of tutoring himself with schematics after shifts. He whispered instructions that the machine obeyed, not because it knew him, but because the physics of it finally had an argument they could all agree on. 48 hours remained on the clock. The investors had their phones poised. The cameras were still rolling. The world had been taught to expect spectacle. It was about to watch something rarer, a reckoning where skill outpaced prejudice. Keep watching. This gets wild. "Stay in your place, boy, before I throw your mama on the street." The words hit like a hammer to the ribs. Whitmore's voice carried the kind of venom that could stain a soul. The room froze. Even the hum of broken machines seemed to stop. Christopher Davis, head engineer, shifted uncomfortably. "Sir, maybe we should at least look at—" "No." Whitmore's tone could cut glass. "Get him out." Security moved like trained reflex. Two guards grabbed Samuel by the arms, ignoring his voice, his raised hands, his quiet desperation to explain. He wasn't pleading. He was trying to save them. But nobody wanted saving from someone who looked like him. They marched him off the floor, down the narrow corridor, and dumped him in the maintenance break room, the forgotten corner of Tech Vantage, where coffee smelled like burnt rubber and hope didn't enter. "Stay here," one guard muttered. Orders. Samuel sat alone, staring at the shattered tablet in his lap. Pieces of glass, bent aluminum, months of work turned to ruin. On that tablet had lived every note, every observation, every clue to the mystery the engineers couldn't solve. He exhaled slowly, pulled out his phone, opened the Notes app, and began to rebuild everything from memory. Line by line, formula by formula. Because Samuel Underwood knew what nobody else did, the Apex 8 wasn't a T dying from hardware failure. It was dying from rhythm. A timing mismatch between the AI's predictive torque modulation and the mechanical stress response, a feedback loop that built resonance at specific loads until the system tore itself apart. He'd seen it before, not in a lab, in his father's garage. A busted bus engine that coughed the same way when torque timing fell out of sync. He smiled faintly, remembering the sound. The problem wasn't the metal, it was the conversation between machine and mind. He knew how to fix it. 90 minutes, a software recalibration, a minor mechanical realignment. Simple, elegant, but no one would listen to the black maintenance worker. Back on the demonstration floor, time hemorrhaged. Hour 12, hour 18, hour 24. Investors grew restless. Headlines hit Bloomberg. Tech Vantage implosion, $500 million failure. Stock down 34%, clients panicking, journalists calling it the end of an era. Whitmore's empire was collapsing, and arrogance had chained the only man who could save it in a break room. At hour 36, desperation had a name. Dr. Elena Vasquez, 52 years old, Latina, legendary in robotics. NASA consultant, 52 patents, unfiltered brilliance. She arrived in jeans and a black leather jacket, no corporate suit, no patience for ceremony. She walked the wreckage like a detective at a crime scene. 30 minutes in, she turned to Whitmore, her eyes sharp enough to cut through pretense. I need everyone who's interacted with this system. Engineers, cleaners, interns, everyone. Whitmore frowned. Dr. Vasquez, we don't have time for... Mr. Whitmore, she interrupted, voice cold and surgical. In 30 years, I've learned solutions don't care about job titles. You hired me for results. Trust me, or I'm gone. He blinked. For once, he didn't argue. Fine, do it your way. 40 minutes later, 85 people filled the demonstration floor. Engineers, janitors, interns, cafeteria staff, even security. Dr. Vasquez scanned the faces, the hierarchy, the silent walls between uniforms. And then she saw him. In the back, grease-stained uniform. Head slightly bowed. A cracked phone glowing faintly in his hand. A housekeeping name tag reading Margaret Underwood. Samuel. The young man Whitmore had thrown away like trash. Dr. Vasquez's gaze lingered on him for a beat longer than anyone else. Something in his eyes, alert, exhausted, calculating, told her he wasn't there to complain. He was waiting to be heard. She smiled, almost imperceptibly. The room didn't know it yet, but history was about to tilt. Because she wasn't just there to fix a system, she was about to give voice to the voiceless. Want to see someone finally listen? Keep watching. Because what happens next restores faith in what brilliance looks like when it refuses to die quietly. Rewind 22 years, South Seattle, a one-bedroom apartment with oil stains instead of carpet. A man named Thomas Underwood, diesel mechanic for Metro Transit Authority. No degree, no plaques, just hands that spoke fluent machine. 8-year-old Samuel sat cross-legged beside him in a garage that smelled of fuel, metal, and faith. Engines were his father's textbooks. Close your eyes, son, Thomas would say. Listen to where the friction is. Metal talks if you pay attention. People lie. Reports lie. But the work? The work never lies. They rebuilt engines from junkyards, motorcycles from pawn shops, even a vintage aircraft motor from a closed museum. For most, it was scrap. For them, it was conversation. When Samuel was 14, A city bus broke down. No one could fix it. $18,000 in parts, 3 weeks wasted. Samuel spotted condensation in the air intake, moisture messing with pressure ratios. He rerouted it with a $40 valve. The bus ran smooth. Thomas smiled, proud but quiet. "Give him the credit," he told the depot chief. "He saw it, not me." 2 months later, Thomas was diagnosed with stage 4 pancreatic cancer. 9 months to live. He made it to Samuel's 16th birthday. "You see things others don't," he whispered on his last day. "Because you listen to the work, not the noise. Promise me, son, never stop listening." After he died, life collapsed like an unfinished engine. Samuel juggled jobs, community college, and the kind of grief that doesn't announce itself. His mother, Margaret, cleaned executive offices for men who'd never learn her name. But Samuel carried his father's principle like armor. The work speaks louder than the title. He studied MIT open courseware on his phone during lunch breaks, memorized manuals, watched engineers work until he could correct their mistakes in silence. At Tech Vantage, he became a ghost, unseen, unheard, underestimated. But he watched everything, learned everything, memorized all 1,238 pages of the Apex 8's technical manual. And now, in that moment of crisis, he held every page in his head, every equation, every fault, every solution. The world had turned its back on him. But when the system broke, destiny didn't ask for permission. It whispered his name. Samuel didn't learn from diplomas. He learned from grease. In his one-bedroom apartment, he'd built a workshop that read like a university syllabus, cobbled with scavenged brilliance. 3D printed replicas of Apex 8 couplings, salvaged bearings, a busted stepper motor from a scrapyard, and a lean bank of notebooks where theory met trial. He'd devoured quantum sensing lectures on his phone, taught himself advanced materials modules, learned Python, and wrestled tensor math into sentences he could use. He'd replicated the coupling's geometry, run simulated loads, and watched the exact same harmonic signatures bloom in his garage that were collapsing the demonstration floor. 6 months earlier, he submitted a maintenance ticket. Unusual harmonic vibration in coupling assembly C4 during high torque cycles. Bradley Hammond chucked it in the bin without a second look. Stick to mopping floors. We have MIT grads handling diagnostics. 3 months later, he was escorted from the engineering bay for reading restricted manuals during break. 2 weeks ago, he emailed Dr. Rebecca Morrison thermal imagery from his handheld infrared probe. The message was auto-flagged and dumped as spam. Once, in the executive parking garage, he handed Whitmore a printout. Whitmore glanced at the uniform, saw Margaret Underwood emptying a nearby trash can, and drove off like he'd been offered a joke. They thought they had silenced him. They only delayed the sound. Dr. Elena Vasquez moved through the crowd like a current. Standing in the center of the demonstration floor, she made the impossible feel like homework. 85 faces, engineers, operators, maintenance, even security, circled her. She looked at Whitmore and said without flourish, "You've got 11 hours. I need everyone who's seen anything unusual. Names, observations, whatever you have." Christopher Davis answered with diagnostics, spreadsheets, careful bureaucracy. The consultants echoed the same dead end: manufacturing defect, unknown mechanism, full disassembly required. The operations manager raised his hand and said, "We noticed unusual vibration during high torque cycles." The engineers shrugged, within spec. Not a failure, they said. Not out of tolerance. That's when Jamal, a maintenance supervisor, said what Samuel had been saying for months. "It sounds different at night. There's a rhythm. When the plant is quiet, you can hear it, like a hum building into a note." Dr. Vasquez's eyes sharpened. "Harmonic resonance," she said. She scanned the room. "Anyone else?" A hand rose from the back. A maintenance jacket. A housekeeping name tag that read Margaret Underwood. Heads turned. Whitmore's voice cut in from above, cropped and impatient, but Dr. Vasquez lifted one hand and it silenced him better than any security guard. "Your name?" she asked. "Samuel Underwood, night shift maintenance." His voice was low, but steady. "Tell me what you've seen." What Samuel gave them wasn't bluster. It was arithmetic, observation, and a lifetime of listening to metal. He explained the timing mismatch in plain, ruthless sentences. The Apex 8 AI samples positional data and issues corrective pulses at roughly 400 Hz. The coupling S material and geometry, particularly at torquey loads between 11,000 and 13,000 Nm, produced a natural mechanical oscillation that at around 12,500 Nm shifted into the same 400 Hz band. When those frequencies aligned, you didn't get damping. You got constructive interference. Each AI correction amplified the mechanical vibration. Each vibration fed the quantum sensors, which the AI then read as positional error. The AI sent more corrections. The system fed itself to failure. The resonance built slowly. That's why the demo survived 40 minutes before minute 43 became a collapse. He pulled up his notes, scrolled to a page filled with numbers and a rough schematic. "I've recorded the heat maps. The spectral sweep peaks at 400 Hz under that specific torque envelope. The sensors are interpreting vibration as positional drift, so the control loop overcorrects. It's a feedback loop that goes exponential." Dr. Rebecca Morrison leaned in. "If that's true, the AI is amplifying a mechanical signature it misreads. You're describing a control system-induced resonance. That would explain the time delay before catastrophic failure." Bradley Hammond snorted. "This is conjecture from a maintenance worker. We've had MIT teams on this for hours." Dr. Vasquez didn't smile. "I decide who's qualified." Her voice was flat, final. "Mr. Underwood, show me your data." Samuel's fingers shook, not from fear but from years of holding tools under fluorescent lights until midnight. He walked to an unused console, connected his phone, and projected a quick spectral plot. Peaks, harmonics, a stalking line where the AI pulse frequency and the mechanical eigenfrequency kissed. The room constricted. Men who'd scoffed moments ago found themselves leaning forward. Emma Wilson and Dr. Rebecca Morrison began to exchange glances that carried the kind of admission you donned to make aloud. "We missed this." Christopher's jaw tightened. Pride tasted sour. Whitmore watched from the glass like a man watching his own obituary being written. Dr. Vasquez turned to Samuel and, in front of everyone, offered a startling permission. "You have access to the coupling housing. Full control. You get one team, 1 hour of override on the AI loop, and I want a live spectral sweep. Prove your model, or I shut you down and we disassemble as planned. But if you're right, you fix the system, and I want a full documented path to replication." For the first time in this disaster, the room buzzed with a different energy. Not panic, but attention. Samuel swallowed, nodded, and straightened his jacket. The name tag looked small against a man who had memorized 1,238 pages of a manual in his head and built a working model in a studio that smelled of oil and optimism. Bradley Hammond protested, voice rising, but Dr. Vasquez leveled him with a gaze. "This is my decision. Step back." He stepped back. As Samuel followed the text toward the coupling, the cameras pivoted. Investors held their breaths. Whitmore felt something colder than fear, the imminence that legacy could be rescued by someone he ID dismissed. Samuel had been invisible for years. Now every eye in the room was on him. He was about to make the invisible visible. "Do you have proof?" Dr. Vasquez asked, and the whole room leaned forward. Samuel nodded, thumbed through his phone, and began to show them what he'd been saving in the dark of night. Thermal stacks stamped with timestamps, vibration traces captured from a handheld accelerometer, spectral sweeps showing a creeping peak migrating toward 400 Hz. Each image was a quiet accusation, each number a witness. Dr. Rebecca Morrison moved beside him. Her eyes flicked from image to image. "This is rigorous," she said, low, the kind of admission that rearranges a meeting room hierarchy. Whitmore's voice echoed from the observation deck, raw and clipped. "Dr. Vasquez, I cannot allow—" She cut him off with a single dangerous sentence. "Mr. Whitmore, sit down and be quiet, or I'm leaving and I'm taking my analysis with me." The floor went still. Nobody told Whitmore to be quiet. He obeyed. "Okay," Dr. Vasquez said. "If your diagnosis is correct, what's the fix?" Samuel's answer came measured, precise, the kind of brevity engineers trust. 2 moves. Recalibrate the AI pulse away from the mechanical band to 418 Hz, creating harmonic isolation, and install damping buffers at coupling mount points to soak up residual vibration. 90 minutes, no full disassembly. The room erupted, some with laughter, others with the quick clattering noise of panic. Emma Wilson called it elegant. Christopher Davis looked like a man who heard both salvation and danger in the same sentence. Changing the AI core frequency could cascade across 51 dependent subsystems. One wrong edit, and they didn't just lose a day, they could brick the whole system. Samuel met Davis's stare. "I know the code base," he said. "I taught myself from the discarded documentation. I simulated the loop interactions at home." He held their gaze. Silence spread like dusk. Dr. Vasquez made a decision that would decide everything. "Mr. Underwood will implement under my supervision. Mr. Davis, your team will observe and validate every step. One team. 1 hour of controlled override on the AI loop. If he's wrong, we stop and disassemble. If he's right, we save the company." Whitmore's protest rose and fell. The word proceed escaped him like a surrender. The demonstration floor remade itself into a theater of precision. 85 people formed a tight semicircle. Investors huddled above, live streams open, media cameras angled for the face-off. Samuel approached the control console like a man who'd practiced this ritual 1,000 times alone. Dr. Vasquez at his shoulder, Christopher Davis and his engineers 3 feet away with tablets up, ready to audit. Phase 1. Diagnostic proof. Samuel didn't rush. Dr. Rebecca Morrison and Emma Wilson exchanged looks that had the small metal taste of regret. Christopher Davis tightened his jaw. Pride and relief warred on his face. Phase 2. Software implementation. This was the hairiest part. The control frequency was not a single magic number. It threaded through the primary loop into 26 subsystems. Samuel outlined a cautious approach. Don't flip the switch. Stage the change. First, initiate an adaptive notch filter in the sensor processing chain to attenuate the 400 Hz band only in the feedback path feeding the problematic loop, a surgical isolation that left position control intact while starving the feedback of resonant energy. Second, apply a phased incremental shift of the pulse timing to 418 Hz within a sandboxed control channel. Run a closed-loop simulation against live hardware in a ratified test mode. Monitor every dependent subsystem. Third, deploy compensating transforms to renormalize timing in the 26 dependent functions. Tiny, verified substitutions rather than a blunt rewrite. Dr. Vasquez approved the surgical plan. Christopher Davis granted conditional access. She typed her credentials and the core opened, a thicket of Python, tensor subroutines, and custom control wrappers. Samuel's fingers moved as if they were retracing grooves he'd carved in his sleep. He injected the adaptive notch, spawned a simulated controller running in parallel, and watched the live spectral sweep. Phase 3. Mechanical correction. While the software sandbox ran, teams assembled dampers, viscoelastic inserts, and tuned mass elements at the coupling's mounting points. Emma Wilson supervised placement to avoid altering load paths. Samuel coordinated the mechanical team like a conductor, instructing torque preload changes and buffer orientations that would convert residual vibrational energy into heat instead of motion. The first test, was the quietest kind of terror. Ramped the system through the torque envelope toward 12E500 nm, while the sandbox controller mimicked production behavior. The live spectral monitor was a heartbeat on a screen. For the first 10 cycles, the 400 Hz spike still crested, a taut reminder of what had been. Then, as the notch engaged and the sandbox pushed its phased shifted pulses, the peak's amplitude began to fall. The curve flattened. The feedback loop lost its feed. The resonance lost its chorus. A cough of relief rippled through the circle. Cameras swung in. Investors leaned forward. Whitmore pressed his palms to the glass as if touching the machine could pull his fortune back into place. Samuel didn't celebrate. He ran the endurance sequence. Repeat cycles for 20 minutes, then 40. Each run showed reduced spectral amplitude, lower thermal accumulation, and a steady, measurable margin beneath the material tolerance threshold. The dampers converted residual vibration into harmless heat signatures. The AI's corrective pulses synchronized to a safer band. The error corrections shrank from exponential to linear decay, and the arms moved with resumed, polite smoothness. Christopher Davis, who had spent hours defending the sanctity of his team's methods, exhaled like a man being allowed to live. Dr. Vasquez's face was unreadable for a beat, then very small, almost a smile. Whitmore watched, and for the first time in 2 days, his mouth opened without a single word. The cameras panned to him. The feeds would show the slow unspooling of a king unseated by a kid he decalled invisible. Phase 3 was the installation, permanent tuned dampers, a monitored rollback plan, and documentation drafted in real time. Samuel S. notes, those same notes he Yeg-D made by phone in a break room while security waited, were being converted into formal engineering orders in front of the room. Margaret Underwood's name tag was suddenly a bookmark on a different story. When the final validation run completed, the spectral plot held below danger thresholds through 3 full production cycles. The room exhaled as one organism. Cameras kept rolling, for posterity, for litigation risk, for the investors who'd thought everything lost. Samuel stood quiet while Dr. Vasquez turned to the crowd and, with the blunt grace of an engineer who'd seen miracles and frauds, said, "Record this. This is how real-world engineering listens." Whitmore's face had drained of color. The man who had tried to make Samuel vanish now watched a boy he humiliated become the architect of his salvation. The auditorium hummed with the new story. The janitor, S. son, who had fixed a 500 million system in 90 minutes. Samuel's fingers fly over the keyboard, fluid, deliberate, and terrifyingly fast. Every keystroke sounds like defiance turned into code. He mutters to himself, "Adjust sensor sampling to 418 Hz. The others just watch, unsure if they're witnessing genius or madness. Dr. Rebecca Morrison leans in, eyes wide. "You're maintaining effective resolution and cutting pulse frequency. Using predictive buffering? That's actually brilliant." Samuel doesn't look up. Second, torque matrices. The timing offset at 418 Hz is 4.3%. I'm compensating by modifying prediction coefficients. He's not just coding, he's conducting. Algorithms respond like trained instruments. Emma Wilson, watching the mirrored monitor, whispers, "No errors, no conflicts. His code's cleaner than our own." Then Samuel does something no one expects. He opens the energy module. 418 aligns better with our power harmonics. You'll see a 6 to 8% reduction in energy draw. Christopher Davis double-checks. He's right. Bradley Hammond's jaw tightens. The man who mocked him now watches in silence, respect dawning behind pride. "Ready to compile?" Samuel says. Dr. Vasquez nods. "Proceed." Compile. Lines scroll. Functions execute. 0 errors, 0 warnings. The Apex 8 reboots. Screens flicker, hums resume. Calm, steady, alive. Emma's diagnostics light up. Integrity confirmed, subsystems aligned, no anomalies. Rebecca breathes out, shaking her head. He didn't just fix it, he improved it. Christopher turns to him. Where did you learn to code like that? Samuel. Free courses, practice. 8 years of watching systems fail until they didn't. Vasquez smiles. Phase 2 complete. Proceed to Phase 3. Now it's hands-on. The coupling assembly looms before him. Precision to the micron. You can't just touch that, Hammond warns. Samuel ignores him. Here, and here, he says, pointing. That's where the resonance lives. From his backpack, he pulls 3 sleek components. Custom silicone dampeners. I built them myself. Emma turns one over, impressed. You made these? He nods. Prusa printer I rebuilt, tuned to 418 Hertz. He installs them one by one, torque wrench in hand, steady, focused. The goal isn't to stop vibration, he explains. It's to break its rhythm. The apex hums back to life. Sensors flicker green. Diagnostics roll. Vibration down 42%. Temperature stable. Harmonics under 0.03. Run the failed demo, Samuel says quietly. Silence, then motion. The apex moves. Smooth, controlled, flawless. 12,000 Newton meters. 12,500. No sparks, no alarms, no failure. This time, the machine doesn't fight him. It obeys. Dr. Rebecca Morrison's voice trembles. Harmonic coupling stable at 0.03. Emma Wilson's eyes glisten. It's holding. The dampening's perfect. Minute 35, 40, then 43. The same minute when the system exploded last time. This time, silence. Perfect, calm, flawless operation. The Apex 8 completes its 132 precision operations without a hitch. Christopher Davis measures, his hands shaking. Dimensional accuracy within 1.8 microns. That's better than baseline. Rebecca runs diagnostics. Efficiency's up 12%. We didn't just recover, we've improved. Someone starts clapping, then another. Moments later, the entire floor erupts. Engineers, janitors, executives, all cheering for the man they once ignored. Samuel blinks hard, fighting tears. Dr. Vasquez steps forward. Mr. Underwood, in 30 years, I've never seen a solution this elegant. You didn't just fix the system. You redefined it. Christopher Davis walks over, eyes full of remorse. We should have listened months ago. I'm sorry. Even Hammond, red-faced, can't meet Samuel's eyes. Vasquez turns to the crowd. Push it, 110% capacity. Christopher hesitates. That exceeds design limits. Then we'll know if it's truly fixed. The system powers up. 16,500 Newton meters. No errors, no strain. Instead, perfection. Efficiency up 14%, stress down 34%. The impossible made ordinary. The room explodes in cheers, relief, joy, redemption. 300 jobs saved because someone finally listened to the maintenance worker. Eyes turn to the glass observation deck. Richard Whitmore, the CEO who once called Samuel boy, now stands frozen. Relief battles humiliation across his face, but shame wins. He doesn't come down. He doesn't clap. He just watches the celebration he's no longer part of. 2 hours later, the boardroom. Dr. Vasquez opens the meeting. We need to discuss Mr. Underwood's future. Christopher Davis slides a paper forward. Senior Associate Engineer, $95,000, full benefits, promotion track. Rebecca Morrison interrupts. Not enough. I'm offering $120,000, lead research position with aerospace. Samuel's stunned. Then Vasquez leans in. I have a third offer. Co-founder, Vasquez Consulting, $140,000 plus profit sharing, full MIT scholarship. Samuel stares. Why me? Because you see what others overlook, Vasquez replies. It's time the industry learned to listen. He shakes her hand. I accept. Within days, the investigation begins. Emails, reports, every ignored warning, 6 maintenance logs, all dismissed. One crumpled by Hammond, one blocked by Whitmore's email filters. The numbers are brutal. $850,000 in emergency consulting, 600 million in market cap loss, 100 million in delayed contracts, 800 in shareholder exposure, all because an 18-an-hour black worker was silenced. The fallout is swift. Hammond, terminated for cause, Davis, reprimanded, Whitmore, forced into a humiliating choice, resign quietly or face exposure. He gambles, stays, and loses. The story goes viral. Maintenance worker saves tech company after CEO ignored warnings. It becomes the talk of LinkedIn, tech forums, and boardrooms. Clients flee, investors revolt. By day 62, the board votes unanimously. Richard Whitmore, terminated for gross negligence. His new job? VP of Operations at a mid-tier plant, one where Margaret Underwood, Samuel's mother, works as a cleaner. When their eyes meet, she says nothing. She doesn't need to. He looks away first. A year later, MIT auditorium. Samuel stands under the lights, receiving the Distinguished Early Career Engineer Award. He's now solving impossible problems across 3 continents. His mother sits in the front row, retired, proud, radiant. He takes the mic. My father taught me the work speaks louder than the title. Tonight I've learned, sometimes the work speaks so loudly, no one can ignore it anymore. The audience rises. Thunderous applause. History rewritten. Not by a CEO, not by a board, but by a man they called a janitor. Fate Tales, where justice, genius, and grit rewrite destiny, one story at a time. Subscribe for more stories where talent triumphs over titles.